Okay, hello everyone. So I want to go over something that I didn't do, which was Diffie Hellman algorithm. And what a Diffie Hellman algorithm is. So Diffie Hellman, this is under encryption. So basically, it's a way of encrypting. It's a way of generating a key. In short, right? Whilst the two people generating the key are communicating through public. So for instance, we have Alice here. Right, we have Alice and then we have Bob here. So basically, Alice and Bob want to start communicating, but the problem is that communication we have it passes through public, isn't it? It passes through the public domain here, where anyone can intercept those communications. So they want to find a secure way of coming up with a way of encrypting their messages, right? Right? Even though they are passing that information through the public, they'll still come up with the same key. In short, so what happens? So I like to represent them like this, right? I like to represent the things like this, but of course you would have to do them in steps. What happens is that, okay, first of all, Bob and Alice in public. So imagine you're talking with someone, right? And there's a third person listening in on your conversation. So what happens is that Bob and Alice in the public domain, whilst everyone is listening, they choose two numbers. This being our generator. So let's say they choose 5 and then another number n being 13, right? Then now Bob and Alice on their own, they choose secret numbers. So Alice chooses 7 and Bob chooses 11, right? So they choose these secret numbers, right? Which is, in fact, let me use a different example because this one will give us and this one will arrive at something close to the answer. And let me use 7. Let me use 13 here, and I'll make this one 17. Yeah. So what happens is that they choose these numbers. Then what happens? First of all, what Alice will do is that she'll generate her XA, right? She'll generate her XA. This will be equal to this A value to the power her secret number mod 17. Bob will also do the same thing. You get this value being equal to the A to the power his Q mod 17, right? So that will then be 5 to the power 7 mod 17. This will then be 5 to the power 13 mod 17, right? So what is the result of this calculation? The result of this calculation is 10 from what I've calculated, and the result of this one is 13, or it is 3. So you would calculate those. So they've done these calculations on their ends. Then what they transfer these values through the public. So this 10 will come here, right? And then this 3 will come here. So they do transfer these values in the public domain. So I'm writing them like this just so I can demonstrate how these values move for you guys. So how these things go about. So yeah, they do transfer those values of theirs. This one goes there, this one goes there. Then now what happens is these are in the domain. So whoever is listening in, the third person listening in on the conversation, you can still get these values. But the advantage of Diffie Hellman is that even with these values and this, they can't do anything with them. Right? They can't do anything. They still can't get to a point where these secret keys are. Then what they do, they then say, okay, the key here, Alice will generate the key by saying, okay, the key being equal to this number that Bob generated to the power her secret number mod 17. Bob also do the same thing. The number that Alice generated to the power his secret number mod 17. And when they do this calculation, what will happen is that they will have the same key in the end, which is 11 here and 11 here. So basically this is the Diffie Hellman schema, right? So whenever you see Diffie Hellman or DH schema, this is what they are talking about. So this is how you're supposed to go approaching these questions, right? Of course you can solve them like one by one, but for me I like to represent them like this, so I can say, okay, this is the public domain here, this is Alice's domain, this is whatever. This is how the values are moving, right? So even given this information here, it's very hard to get to a point where you can derive this one and this one. Quite right, you can do it, but the bigger these numbers, the more time it will take you to do this. And that's why this is a very good encryption algorithm. So this is a short one going over Diffie Hellman schema. If you have any questions again, feel free to forward them.